Hey everyone, sorry I can't be there with you in person today, but hopefully this little video can just get you at least started with the process of calculating equivalent resistance for more complex circuits that don't have just series or just parallel, but have some combination of both of them. So here we've got our first sample problem. And the first thing I always want to do to analyze my circuit is to trace out all the different pathways that current can take through it. So I know current always starts at the high potential end of the battery. So let's start right here, move this way, and then we reach a junction, which means that our current's going to split. Some of it's going to go down this way and back over to the low potential side. And some of our current, again, will start at the high potential side. We'll go through the 6 ohm resistor and then go the other way through the junction and down and up. So what I can see from this, sorry, I'm trying to hold the camera and do this at the same time. So what I can see is that there is a junction where the current splits right here, and then that current comes back together again over here at this other junction. Okay, now my rule for equivalent resistance is to always start by focusing on things within a junction first. So I'm just going to focus on everything that happens between this point and this point. I'm going to block out the 6 ohm resistor for a little bit, and you'll see why later. But basically, I'm just going to focus on this parallel section first. So I've got 2 parallel pathways that I would like to condense down, but before I can do that, I need to make sure that each pathway only has one resistor on it between these 2 junctions, between these 2 purple dots. Now, for this pathway, with just the 5 ohm resistor, I'm good. But over here, this other pathway has 2 resistors between the 2 purple dots. I've got a 5 ohm resistor and a 15 ohm resistor. But the good news is that I already know the connection between these 2. They all have the exact same current going through them. These 2 resistors are in series. So I'm going to start by combining those 2 resistors in series. And to find equivalent resistance of 2 resistors in series, all I have to do is just add them together. Okay, so that means the equivalent resistance of those 2 resistors is 20 ohms. So now that I've done that, and this is a really key thing, and please do not get lazy on me here, I'm going to redraw this circuit, replacing those 2 resistors with the equivalent resistor that I just calculated. So I'm going to redraw the whole thing. Okay, my 6 ohm resistor hasn't changed, so I'm going to leave that alone. My 5 ohm resistor hasn't changed, so I'm going to leave that one alone. But then on this outer branch, instead of drawing those 2 resistors, the 5 ohm and the 15 ohm, I'm going to replace it with a single 20 ohm resistor, because this is equivalent to those 2 together in series. This one resistor has the same effect on the circuit as those 2 resistors together in series did. Okay. So this circuit is equivalent to that circuit. Now I still want to focus in on my parallel section, so everything between these 2 purple junctions right here. But now I see that each pathway between the 2 junctions, from here to here and then from there to there, only has one resistor on it, which means that at this point I am ready to add these 2 resistors together. And these 2 resistors are in parallel with each other, which means I'm going to need to use my parallel equivalent resistance equation. So 1 over equivalent resistance is equal to 1 over 5 plus 1 over 20. And when I do 1 over 5 plus 1 over 20, and you can just put this directly into your calculator and do all that, you'll get 1 over equivalent resistance is equal to 0.25. Now that does not mean that I am done there. That's not my equivalent resistance, this 0.25. 1 over my equivalent resistance is equal to 0.25, which means that to solve for what the actual equivalent resistance is, I can either do 1 over 0.25, or I can do, 0.25 to the negative 1. And those two are equivalent to each other. So you can either do 1 over whatever your answer here was, or take that answer and raise it to the -1 power. It's the same either way. Either way, you'll get an answer of 4 ohms. So I'm going to go ahead and redraw my circuit one more time. All right. So my 6 ohm resistor has been very patiently waiting this whole time. And now I'm going to take this whole mess of stuff that I just calculated and replace the whole thing with a single 4 ohm resistor. Now notice at this point, I no longer need 2 parallel branches. I've already collapsed that whole thing down, so I don't need to have 2 separate pathways, 2 junctions there. It gets replaced by one single pathway with a 4 ohm equivalent resistor. Well, now I've just got a 6 ohm resistor and a 4 ohm resistor, and those are in series with each other, and I know what to do with that. I just add them together. So now my equivalent resistance be equal to 6 ohms plus 4 ohms. So then the equivalent resistance of this whole circuit is 10 ohms, which basically means if I go back to my original circuit, this whole circuit here will draw the same amount of current from the battery as just a single 10 ohm resistor would have. So that's the basic idea behind equivalent resistance.